The graph shows how the angular acceleration alpha of a flywheel varies with torque tau applied to the flywheel. What is the moment of inertia of the flywheel? We know that torque is equal to the moment of inertia multiplied by the angular acceleration. Using any point on the graph, for example this point for which alpha is 10 and tau is 2, we can see that the moment of inertia is 0.2, so A is correct. The next, an ice skater is spinning with the arms extended in a fixed position at a constant angular velocity. The ice skater then quickly pulls their arms closer to the body. Frictional effects are negligible. 3 statements are made about the ice skater's motion. Which of the statements are correct? There are no external forces rotating this object. There are weight and normal reaction, but they act in direction of the axis, and hence the perpendicular or the shortest distance is 0, hence a moment of force or torque is 0. So the third statement that the net torque acting on the ice skate is 0 is true, and hence it can be treated as an isolated system or a closed system, and hence the angular momentum I omega is conserved. So I1 omega 1 is equal to I2 omega 2. So the first statement that the angular momentum of the ice skater remains constant, it's true. And when arms become closer to the body, it implies that the moment of inertia decreases, because the moment of inertia shows how far from the axis mass is distributed. So the moment of inertia decreases, hence the angular velocity increases. And what about the rotational kinetic energy? It's I omega squared over 2. I write like this. Initially it's I1 omega 1 omega 1, and then it's I2 omega 2 omega 2. And from this statement, I1 omega 1 is equal to I2 omega 2, but omega 2 is greater than omega 1, hence the rotational kinetic energy of the ice skater is not constant. So the second is not true. So B is correct, and that's all for this question.